I'm going to talk today about a new feature in, well, not so new, but a feature in Red Hat Gateway. It's been there for a couple of months, and it's been evolving. And this feature is mainly, it's the PubSub feature. And I'm going to tie that into the hybrid cloud story and use cases, and show how in combination with other things we can achieve more openness. This, in one of the keynote, Gerald from SUSE said that being open is more than just the source being open. And I think this relates to this in the sense that this feature demonstrates how opening the product to the ecosystem can facilitate many use cases. So I'm going to first explain a couple of minutes, spend a couple of minutes explaining a little bit about Knative and Kubernetes, then about the PubSub feature in Ceph, and then a demo, hopefully a live demo. So, Knative. Knative is a framework in Kubernetes that is built to allow serverless function. It gets you to build the function, to trigger them, to monitor them, and to invoke and run them. In our case, we're just using a subset of what Knative can provide. And this is a component called eventing. And this is the reliable event delivery, spreading the events to multiple recipients inside the Knative world, and so on. And serving, which is the invocations of the serverless functions, scaling them up and down. Not going to really show scale up and down. Well, in a sense, I will, because you would see that the pod executing the function doesn't exist until a message arrives, and then it's going to scale up and create one instance. Couple of words about serverless, just because it's a Ceph conference, so maybe not everybody is so versed in those terms. Serverless is on a spectrum of moving between bare metal, where you need to do lots of ops, through VMs, through VM orchestrations frameworks like OpenStack, containers where you have to do even less ops, and container orchestration is Kubernetes. When we talk about serverless, you don't need to deal at all with the server. The only thing that you need to do as a developer is write your function, write your code, and then somebody else is invoking it, somebody else is writing the main loop, waiting for messages to arrive, and the only thing that you need to care about is your business logic, and that's it. So this is the term serverless, just to make sure that we're on the same page. And this is a very appealing thing for simplicity, because developers want to develop fast and deploy fast, don't care about lots of stuff. It's also sometimes cost effective because it runs only when you need it to run. It doesn't always run. So this is why it's a very appealing term. It's just not just a hype. And this is why we want to show how Ceph can use such a function. Okay, so what was done in Ceph for PubSub? A little bit about the architecture of how we did that. So we're kind of building on the sync mechanism. So sync mechanism wasn't intended to do PubSub or anything like that, but it is to sync different the metadata or the data and metadata in different zones. But the nature of it, that you have a Red Hat gateway that gets notifications about something that's happening, it gets all the reliable delivery, it gets an ACK mechanism, it gets a retry mechanism, lots of good things that are in place that allows you to write something that can do publishing of events. Now, the code architecture was done in such a way that it is easy to add a new module. So there are only a couple of modules taking advantage of this syncing mechanism. Those are called sync modules. And again, they get reliable delivery, they get hacking, retries, everything. And they are implementing all kinds of things. I think Sage listed some of those things as communication with the syncing to the public cloud and a couple more things. I don't remember all of them, but he listed them in his talk. So we've built just another module like that, which is a sync module. It's getting the events, getting the metadata from the main zones, and what it does is PubSub. So the basic functionality is just taking the event and storing them in Ceph itself. So that doesn't really publish anything, but the events are there, and if somebody wants to pull them out of Ceph, it can. So this is the most basic functionality. You don't publish anything. You are kind of the message bus or the storage for the events. They're stored inside Ceph, and people can pull them out. This is what we call pull mode. But on top of that, we had a couple more things. So when people talk about publish subscribe, they usually want to get the event out of your system. And we currently have two mechanisms or two protocols on which we can send events out of the system. One of them is HTTP. Those are HTTP posts, and there is a JSON payload where the actual content of the event, of whatever happened in Ceph, is going to be sent. Another system that we can connect to is using MQP. We're using MQP 091, which doesn't really matter, but this is what RabbitMQ, which is the most prevalent MQP implementation or common out there. So this is what they use. Once you send the message to something like MQP, then your problems are over because they have reliable storage, they have reliable delivery, they can store event, they can push the event, people can pull the event from them. Like, it's a whole system that is meant for that. And more important, those are systems that exist. I mean, people that are running Ceph or want to run Ceph, in many cases already have some kind of message bus. They often have RabbitMQ. So when they're adding this functionality, then they're going to get all the events into a system that they already have. Things that, and the reason we also support HTTP, you will show that, because this is what I'm going to demo. It's very, well, it's not like there are lots of servers that waiting there for getting HTTP messages, but it is so common that it's very easy to convert it into something else that exists, to other systems that exist. In the future, hopefully the near future, we're going to add a couple more native protocols that we're going to support. And this is, of course, Kafka, which is very similar to MQP, more modern maybe. ActiveMQ, which is MQP.0, and this is also a common implementation of MQP. And on the right-hand side, and this is I'm going to dwell about that a little more later on, AWS Lambda and Knative, which are the serverless functions. By the way, they're using HTTP, but a certain flavor of HTTP. Couple words about the data model. So how do we define and configure or provision the system to use PubSub? So the first building block that we have are topics. Again, topics is the term taken from Kafka and AMQP to define some classification of messages, because this is what those message buses brokers eventually use to send those events all over the place where people need them. And inside the topic, you can also define the endpoint. This is how we done, like if you ever interacted with AWS SQS or SNS, one of those guys, then this is how they define the topics there and their endpoints. So we kind of borrowed the same concept from them. Then we have subscriptions. Subscriptions are definitions that associate a certain bucket with the topic. So this is what makes things happen, because what we're monitoring are events happening on a bucket, and we want to associate that with a topic so we know what to do with those events. If no endpoint is defined, we just store them locally, and then they can be pulled out. This is the pull mode. If an endpoint is defined, then we're going to ship that to the endpoint. And a little more thing about the subscription, you can also define a filter there, because sometimes you don't want to get all the events that happen on a bucket. Sometimes you want to get only the object creation. Sometimes you want to get the object deletions, which are the two types of events that we currently support, but in the future we'll add more refined triggers of the event, like differentiate the start of a multi-part upload from the end of a multi-part upload, and so on. a little about the data structure or the way that we structure the data. You can use the same topic for multiple subscriptions. Let's say that you have an MQP server, this RabbitMQ server or broker, then you probably want to send many topics to it. So you can define a topic or many things happening to it. So you can define one topic and say, this is the topic. I don't care exactly about the bucket. It's one topic getting messages from multiple buckets. And then I'm going to create multiple subscriptions with the same topic, all coming from different buckets sent to the same, funneled to the same place in the RabbitMQ server. And sometimes you want to have different topics, maybe on the same bucket, with different filters, for example. So you want to have a topic of object creation on bucket X, or you want and a different topic for object deletions on bucket X. So for the same, you can define multiple subscriptions on the same bucket, and the filters could be different. As I said, we reused in a very nice way the existing infrastructure that Sage spoke about. He called that Multisite. It's not a great name. It's like the syncing of multiple sites, but it has nothing to do with multiple sites. It is just using leveraging the mechanism to send that to completely different other entities or outside of Ceph. The thing is that, and when we are the broker, when we store the messages, then that makes perfect sense, because we need to store those messages, and we are the message bus. We're storing reliably those messages, and Ceph is the best reliable storage we can think about. However, when we're sending things outside, those are reliable kind of message buses by themselves. So adding this extra layer of reliability could be an overkill. It could be something that we not necessarily want to or need to have. So for example, if you send something to MQP and there are clients that want this information, but for some reason they're disconnected and so on, MQP or the RabbitMQ broker will take care of that, would put that into reliable storage, and whenever those clients wake up, they're going to go and fetch the information from RabbitMQ. So there's very little point in also storing that information inside Ceph in this case. So in the future, we plan on adding something called a push-only mode, in which the messages could go out directly. Now, if this is the case, we may decide to build a more integral and native support for sending those messages outside of the system without this extra zone. This extra zone, this extra zone here that you see, zone C, well, it doesn't cost too much to add that, but this is again a little extra thing that you need to configure in your system. So if in your system you really have zone A and B, adding zone C just for PubSub could be perceived as an extra piece of configuration that you don't necessarily need. And if in this case of a push-only mode, we don't really need it for any functional reason, then in the future we may want to avoid that. This would give us a little more availability. So in the sense that, well, object creations and deletions are usually important pieces of information, but if we're more tightly integrated, we may be able to add more ephemeral events to the mix. And those may not have some strict requirements on delivery. So let's say that we have events that if they got delivered, it's good. If they didn't get delivered, nothing bad happened. So those events may not even be needed to persist it to any or persistent memory. So for example, if the Redis gateway crashes and restarts, events are lost, might be okay. Again, depending with the type of event. So this is another kind of drive towards this more integral implementation. But this is in the future. Okay, a little bit about the demo. So what is the background story? And I'm not a marketing guy, so if any of you guys are really users of Ceph, you can come up with better stories than mine. So let's say that we want to do image classification. I'm not very original on this one. But let's say that we have two types of people that want to classify the images, the cat owners and the dog owners. And from some reason, we have our own excellent cat classification algorithm that we built in-house. We don't want to put that in the cloud. It's very proprietary, very special for us, and we trust it. For the dog owners, we don't mind that Google Vision or AWS Recognition or who knows what going to classify our dogs because it's, I don't know, less important or no privacy issues or whatever. And for cost effectiveness or whatever reason you can come up with, we want to do this processing in the cloud, in the public cloud, not in our on-premise cloud. And again, those are just things I made up, but I can pretty much be sure that any of you that actually use those systems can come up with cost, performance, bandwidth, privacy, whatever real reason of why you want to do some processing on your on-premise cloud and some processing on the public cloud. A little bit about how the, I hope you see that slide. So a little bit about how the setup is made. So we have a private cloud that runs a Kubernetes cluster and a Ceph cluster. And we're also connected to a public cloud, AWS in this case. What do we have in the Ceph cluster? We have two Redis gateways. One is the main zone where you get the images to. The other one is this specialized PubSub zone that is used for the PubSub notifications. In Kubernetes, we're using Knative as the framework. And it has an entry point, and this is what this HTTP destination or endpoint that I mentioned before. And this is going to get the notification from this specialized Redis Gateway PubSub entity. And what it's going to do, it's going to put those messages into the Knative channel, which is their common bus. And there's some definition. I'm going to show you the YAML later that's going to invoke the serverless image classification function, our special source algorithm for classifying cats. And that's going to go and fetch the image, because everything that we're syncing and doing with PubSub is not the images themselves, of course. It's only the metadata. So once they're going to get a notification that a new image was uploaded into Ceph, they're going to need to go and fetch the actual image. And once they get the image, they're going to do the processing, and everybody is happy because it happened where it needed to happen. Then, if somebody is going to upload the dog into the dog bucket, then we're going to know it's a different bucket. We're going to have a different subscription, different topic, and all that stuff. And this topic is going to have a different endpoint. And the endpoint that this topic is going to have is this small connector called HTTP to the AWS. As I said before, the HTTP is a very basic destination. And the payload is the JSON payload that we're sending, but the actual REST API is kind of different. So a plain HTTP post is one flavor of the API. Knative is a slightly different flavor of the API, and AWS is a third flavor. So this is why we need a little bit of connectors like proxies. They're sending the same payloads, but a different command, REST command. So this is why we need this small process called HTTP to AWS. Once we have that native into this Redis Gateway PubSub mechanism, then those connectors go away and everybody's happy. Again, the API gateway inside AWS is going to invoke their Lambda, and the code that I uploaded into the Lambda function, what it does, it's going to go and fetch the actual image. As I said, this is only the name of the bucket and the name of the object. They're going to fetch it, do the magical processing, and everybody's happy. So, as I said, just reiterating that, we're going to create two buckets, and we're going to create two topics and subscriptions. One's going to send to the HTTP to Knative process. The other one's going to send to the HTTP to AWS process. Those are just converters, just changing how the REST message looks like. Same payload exactly. And as I also already said, we're going to get rid of this in the future. And if there's some other cloud providers that's going to have a very a good use case for us, and people would like to have native support, then again, it's pretty easy to add those destinations. It's the same payload, different REST message. If we want to use Lambda function or serverless functions from other cloud providers. The setup there is pretty trivial. As I said, defining a serverless function is really easy. You just write the code. You don't need to write any server that gets HTTP message or anything. You just write the code. Somebody else is invoking this function, taking care of everything. The only gotcha here is that you need to actually go and fetch the image. So you'll need to put the right credentials in place, whether it's inside Kubernetes or inside the Lambda function, to go and fetch the image from Ceph. So those credentials, you need to somehow pass that up there and make sure it's inside a secret, or make sure it's protected. Inside Kubernetes, I didn't say that, we're using Istio. This is to make the whole thing of communicating between Kubernetes in and out easier. So you configure, it's called the services, in one place, and you don't need to open ports manually and so on. So I'm going to try a live demo. Okay, so here I'm just, as I've said, the first step, hopefully this is visible. First step would be to create the two buckets. So let's just do that. So I'm going to create one bucket for my cats and one bucket for my dogs. Okay, buckets created. Now the next step that I need to do is configure those topics and subscriptions. So I can't really use the standard tools for that because they don't know how to speak those language of creating subscriptions and topics. Although Bodo 3 does support creation of topics and subscriptions. So you can actually use that in order to create topics and subscriptions inside Ceph. You have to make sure, I mean, in Bodo 3, when you create a topic, it's like you're creating a topic on AWS SNS, which is not going to be the case, but it's the same format. So we're compatible with format, so you need to tweak that a little bit, but pretty much you can use Bodo 3 for that. So the first thing I'm going to do is I'm going to create a subscription. Let's start with this. Subscriptions, so the topic, I'm creating a topic for the dogs, and this topic has an endpoint, which is this local translator that's just going to translate the messages from plain HTTP into the AWS Lambda HTTP that invokes the function. I'm going to say that I'm going to create a topic and associate that to the dog basket, which is where the dog images are, and even give this subscription a name. And I mean, this little script also does an extra thing to go and fetch some events. So I have some old events that I didn't bother to delete. Okay. I'm going to show you the event later in a nicer way. And then I'm going to also create one for the cats. Now, the one for the cats, again, I'm going to tell it which bucket to use. I'm going to give it a name. The topic is cats. And I'm going to give it an endpoint, which is whatever runs inside Kubernetes that's going to take those HTTP messages and convert them into Knative messages, which are also HTTP messages, just a different flavor. So this one also worked. Okay, so now we have the configuration. Everything is configured. We have the buckets. I need to make sure that this translation process works. So this is the process that converts from the plain HTTP to AWS. As you see, when I defined the endpoint, I defined on port 2001, and here I'm going to listen on port 2001. I'm also going to ACK messages, ACKing them in just telling the PubSub mechanism that I processed the message, it's not needed anymore, and then it's being cleared up. Otherwise, there's a rotation of a couple of days, I think. So this one is going to wait for this is the endpoint of the dogs, and it's going to send them to AWS, hopefully. And the last thing is that we said we are running something in Kubernetes. So maybe have a quick tour through the YAMLs. So the first thing we're running in Kubernetes is the thing that translates from HTTP into Knative. It's a pod, if you know Kubernetes, but they call that a container source in the Knative language. And it also does the hacking. This is why it needs like the subscription name. And this is where it is doing the hacking. So this is the Redis gateway Ceph. As I showed you in the diagram, there are like two Redis gateways, one where the actual data is and one only for PubSub. So the hacking you do in PubSub, so this is what we put here. And what does it do with the things? It put it in a channel. The channel is this common message bus in Knative that spreads the information. So this is the only thing this translator does. And as I said, once we have Knative natively inside Ceph, we don't need this to run at all. The channel, the definition of a channel is pretty simple, just a name and a couple of attributes inside the Knative. And there's also a subscription. So subscription is something that ties a channel or messages from a channel into invocation of the Lambda function. So here you can see that it ties the channel that was defined beforehand into a service. The service is the function. It needs some information, like because later on it would need to fetch the images. So it would need to contact the Redis gateway and fetch the images. This is why it needs those secret parameters. And under the hood, it just uses Google Vision, which kind of not very pretty because I said we have a secret sauce algorithm. We don't really have that. So this is why it needs an API key for Google Vision. And if you want to look at the function that it invokes, so this is the definition for the function that it invokes. And what this function does, it has the name of the Ceph. It is using port 8000, not 8001, because 8000 is where the images is. 8001 is where the PubSub and the hacking is done. So it needs 8000 because it needs to get the images from there. And it has the Google API URL because this is where it actually does. This is where the secret sauce is. It doesn't exist. Okay, so those are the YAMLs. And if I'm going to see what's running there, so what I can see is only the translator pod is running. So the actual function doesn't run because, as I said, it's on demand and nothing demanded it so far. So for it to be demanded, let's upload an image. So I downloaded a couple of dogs and cat images from Wikipedia. And let's start, let's start with the dog. Now the dog, as I said, is going to the AWS one. And okay, let's see what it says. So this is the translator, and what we can see is the translator got an event. This is the PubSub event, an object create, got a timestamp and information, and this is the dog basket, and it also got an object called dog3 JPEG. And because the dog basket is associated with this endpoint, this is why it got the message. What this one does, it just takes the same payload, the same JSON payload that you see here, and changes the REST message and set it to the Lambda function. And what the Lambda function told it is that it's a mammal, and well, it also said that the dog somewhere, oh yeah, here. Well, kind of. Anyways, this is what the Lambda function told the algorithm. And we can maybe try another one. Hopefully this one just said dogs at the beginning. Let's see. Yeah, this one is better. So this one is a different image and it says dog. Now, what about if I'm a cat owner and I'm uploading an image to the cat basket? So let's upload an image to the cat basket. Let's see. Okay, so what do I expect to happen now? I send this message. The subscription tells it that it went to the cat basket, and the subscription of the cat basket has a different destination. Destination now is this serving pod inside Kubernetes. And as I said, what this one is doing, the translation from the plain HTTP, same JSON payload, different REST message, and put that into the Knative message bus. Once it's in the Knative message bus, what Knative knows how to do is that looking at the Knative subscription, it knows how to invoke this Google Vision pod, run that, and let's see what it says. So first of all, I need to see what's running here. So I see two pods now. The first one, this is the translator pod always running. And the second one, this is the pod this is the Lambda function. So let's see what the logs. Now it's going to be a different name every time because it's a Lambda function, and if it's going to be inactive for a while, it's just going to go away. So if I keep on uploading images, then it's going to still be the same pod. But if I don't upload an image for like 2 minutes, then it's just going to go away. Okay, so this one contacted Google Vision. He got the object, cat4, and gave it a score. And even said it's a cat. Let's try another one just for the fun of it. You know what? Let's try to upload the dog. That shouldn't matter because it's not a special algorithm. You see, I upload the dog, but it's to the cat basket, so the subscription doesn't send anything here for where the dog should go. And hopefully it's the same. Yeah, it's the same function. And this one says it's a dog. Well, good algorithm. Okay, this is pretty much it. If you have questions or anything to say. Okay, thank you very much. Oh, there's a question? Sorry? Okay, thank you guys. At booth. So if you want to see more details about the demo and everything, then yes.
What's the availability of this?
What I showed now, it's in the upstream. You can just fetch the latest, compile, and get it. Also, sorry, one last thing. The actual demo, if you want, like all those small connectors and YAMLs and all that stuff, it's also like exists. It's called the RGW PubSub API under the Ceph kind of umbrella. So all the code and some instructions, not great, but you know, if most people can figure that out, exist here as well. Okay, thank you.